We provide two releases from Compat Wireless. One is a daily snapshot based on Linux Next. The other one is based on the current RC cycle of Linux kernel, and also of future updates of the extra versions of the releases of Linux kernel. At times, though, it may be desirable to cherry pick a specific stable release of the kernel for a customer. We accomplish this in Compat Wireless by categorizing patches or extra patches apart from the actual code that we're pulling from this respective Git tree that we're using to collect code from. As noted, we have two types of releases, bleeding edge release and also stable releases. It only really makes sense to cherry pick changes into a stable release, given that everything that's being posted will be merged into the respective development Git tree. There are four types of extra patches. One of them are the types of patches that are present in Linux Next, which have been marked as stable fixes, but those patches have not yet been merged into the Linux 2.6 all stable Git tree. The Linux 2.6 all stable Git tree is the Git tree used by maintainers of the stable releases of the Linux kernel. That is the extra versions of the Linux kernel. So, for example, 2639.1, 2639.2, and so forth. Next are the types of patches that are merged into Linux Next Git tree but are not marked as stable fixes. We call this Linux Next cherry picks. Then we also have patches that are posted publicly in a mailing list but are not yet merged into the respective development tree. And finally, we have those patches which have not even been posted yet. We do not want to propagate these type of patches. We want to prevent these type of patches from becoming popular, and we want to restrict developers from promoting the idea that these patches are even possible to be integrated into releases. Because of this, we categorize this and label these patches as crap. Some distributions make use of Compat Wireless to enable users to get support for new hardware by creating a package based on Compat Wireless. Some other distributions will likely take Compat Wireless code and actually merge that code as part of their own kernel. Some distributions don't actually even like to use Compat Wireless, but their users end up using it anyway. Some other distributions simply have a policy of only using stable kernels and anything that is present in the kernel, and that's it. ChromeOS is an example of a Linux distribution that has embraced Compat Wireless, but that will eventually migrate to simply using code that is just merged part of the Linux kernel. You can identify the version of Compat Wireless by looking at the DMS log. If you don't see anything identifying the specific version of Compat Wireless, you can try to load the module called Compat, and that should print out the specific respective Git tree that was used to pull code from the Linux kernel, and also the code metrics. End users and customers should typically just stick to the stable releases of Compat Wireless, or the stable releases of the kernel, or the releases of the kernel from your distribution. If you have a feature that you know that is required for a customer or for an end user, you could simply have those patches merged into the stable release of the Compat Wireless by submitting them to me, and I will merge them without any question. My only requirement for those patches is that those patches fit one of the categories that I explained before, and you should identify the patch by placing them in the respective directory that they fall in. Alright, let's move on to debugging. To debug 8211 Linux drivers, you should simply first think about the notions of user space and kernel space and the separation of it and what each component actually is doing. Let's review a little bit about that now. There are two ways that you can interact with 8211 devices. One is by using the CLI, essentially a terminal, and just typing in commands. The application that you want to use for modern 8211 Linux drivers is called IW. That will help you debug, do manual scanning, do manual association, this is disconnecting from an access point, setting encryption, and so forth. if you want to actually use a connection manager, you have several options for Linux. One is by using Network Manager. An example of a Linux distribution using Network Manager is Ubuntu. Another one is Fedora. Other distributions use another connection manager like Conman. An example of the distribution working with Conman is MeeGo. Chrome OS actually forked Conman and renamed it to FlimFlam. Both Conman and FlimFlam use NLRT11 exclusively. This is actually where we want to get Linux distributions to be. We want them to only use NLRT11. So let's backpedal a bit here. If you want to debug an 8211 device, first thing you want to do is actually get rid of the GUI interface component and disable that. And then you want to use the supplicant manually. If you're still having issues, you may want to disable the supplicant and try to connect manually. If you still have issues, then you will likely want to start using debugfs, which is the file system that we use to expose some statistics or get the kernel log. Though not required, I typically recommend upgrading your supplicant just to be sure that you're using the latest code